Software Engineering 2022 is making a big effort to connect with folks who also do research software. Typically, when I talk to software engineers who talk about research software, this comes pretty much from the perspective of, oh, this research software is also awful. It's badly modularized. They don't do people don't do proper testing. And sometimes if you have research software in humanities, you even have to start with very basics such as naming variables properly and other stuff. That is mostly correct. But however, you will also find out that people who actually do research tend to be smart people, and they actually can solve many of these problems without ever having the need, without ever needing help from software engineers for that. And so it's actually fun to explore what people are doing in research software and figuring out that, well, sometimes there are things that people in research software can learn from software engineering, but interestingly enough, it can also be the other way around. And today I'm going to talk about concepts that actually were introduced to support research software and concepts where we as software engineers can actually learn something from. So now let me see if I actually can advance my slides. Okay, cool. Yeah. So a bit about me. This is CISPA, the Helmholtz Center for Information Security. Big new research Helmholtz Center in Saarbrücken in Germany, set up to grow to about 600 researchers, depending on the week. It can also be 700 or 800 researchers, depending on which funding sources you bring in. All devoted to information security, and it's amazing to work in a center that keeps on growing and growing. Already today, if you look into CS rankings and look for the top venues in the world in computer security, you will find that the CISPA Center is at the very top, which is really great. However, these rankings are to be taken with a grain of salt because CISPA is also here at the top because there's quite a number of faculty working in security. If you break this down by publications per faculty, we're pretty good. But if you look further down in CS rankings and look, say, for software engineering, you will find that CISPA is somewhere down in the list because, well, I think, the only person who does software engineering there, and I alone cannot bring this whole center to the top. But still, it's a great place to be in, and our German government is pretty proud about it and touts this, that we have a center that is number one whatsoever. And as Andreas Vogelsang already has pointed out, I am happily doing research and teaching and programming in two areas. One is fuzzing, that is automated test generation in various ways, and the other one is automated debugging. And I have indeed written two textbooks, which are called Fuzzing Book and debuggingbook.com. .org. And these textbooks actually they are all online. They are written, they come with code and text and plenty of examples of how to use this code. And the way I have built these is not in the classical style, say using Word and copy pasting and examples and everything, but rather using a tool set that all came from research software. And this toolset is known as Jupyter Notebooks. I wrote these entire books, all the chapters in Jupyter Notebooks. I programmed them all in Jupyter Notebooks. And for those of you who've never heard of Jupyter Notebooks before, Jupyter Notebooks are documents that bring together code. So far, so good. They bring together text, and they bring together diagrams in one single representation. The nice thing about Jupyter Notebooks is not only that they bring all these elements together. I mean, you could also create this document as you see it over here using LaTeX or Word or anything. No, the interesting thing is that they're actually executable, meaning that you can execute the code right within your notebook, and you can execute this code also to actually generate outputs. The outputs also become part of your notebook, and outputs can also be very rich. For instance, the diagram that we see up here is actually created using code. So a few ideas on here. Things that you can do with notebooks is, for one thing, you can do standard literate programming. Standard, I know I know that literate programming is not so common, but the idea here is you are writing a piece of code, and at the same time you're writing down your thoughts, you're writing down what you are explaining what you're doing, and you're explaining it to a human reader. Much more than with comments. In comments, you can only go that far. No, you have a very rich environment in which you can use all sorts of diagrams, all sorts of examples too, which actually goes beyond literate programming to illustrate things. In order to write these documents, you do have a rich set of languages to work with. Essentially, it's all Markdown. Markdown is a very simple markup language in which you can very easily create pretty readable and pretty well formatted documents. But you can also include LaTeX document. You can also include LaTeX, or you can also include HTML, and you can also include JavaScript for the fun of it, meaning that you can even create text that actually is interactive, because there will be JavaScript running in your browser. Next thing is outputs and examples, and that's where we definitely leave the old idea of literate programming, because you can actually include all the output of any program fragment right within your document, which allows you to illustrate your code right away. After you've written a function, you can give examples of how it works and what it produces. And you can also include interactive elements such as quizzes in there, which are all neat for all sorts of interaction. And when I talk about rich outputs, this is really extremely rich. For one thing, you can make use of all the tools that are being used in data science to visualize data sets in all sorts of ways. This is extremely rich. It is truly the tool of choice if you want to dwell deeper into big data sets. That's what it was mainly created for, and that's what one programmer after another creates yet another visualization, creates a package that you can use again. But you can also write your own visualizations. This, for instance, here is a visualization of statistical debugging in which lines whose execution is correlated with failure are highlighted in red. So we see this. Or that over here, line 6, which is the line that is actually buggy, is actually colored in so-called tarantula style. Of course, we already have seen that. You can also output formulas and render them. You can also come up with box diagrams and visualize things. This is a visualization that I created. This is a visualization of information flow in a program. You throw in a Python program, type a line, and out pops an entire graph with all the information that you need. So these are all things that you can produce. Here's a class diagram. This is also something I programmed. I wanted nice UML style class diagrams, so I wrote a little package that would take a Python class and visualize it together with all its methods and the whole class hierarchies and everything. So these are things that you can use and that you can also build yourself. And this goes way beyond. This goes way beyond what you've seen in classical literate programming as it was conceived by Knut early on. I'd like to give you a very brief demo of what such a Jupyter notebook looks like. And for this, I'll just switch over, and I hope you can see things over here. I think I can make things still a bit bigger over here. Okay, here we go. Okay, wonderful. Let me just see. I used to have a cheat sheet, and I cannot find it right now. Okay, let's do this without a cheat sheet then. Okay, so what I have here is a very simple example. I want to create a factorial. So what you have here is you have the Jupyter document, which comes in as a form of cells. Here we have a text cell, and in this text cell, I already have put in some text in here, markup text. And as you can see, there's also LaTeX in here. So we already have a formula, computes the factorial of n. Actually, now that I see this n here is actually not properly rendered. So this is what it should look like. And now I can actually go and write a factorial function. Let me see whether I can build a factorial function right away. Definition of factorial, oh, sorry, pressed the wrong button here. Definition of factorial n. What would that be? Return 1 if n is less than, return 1 if n is less or equal than 1. Otherwise, it is definitely n times factorial of n minus 1. So let me assume that this is correct. Boom, at least it's syntactically correct. And now I can actually immediately verify whether things work correctly. So let me see whether factorial of 3 actually properly returns 6. Yeah, that's actually correct. Factorial of 1 is 1. That's true too. Factorial of 2 also returns 2. This is exactly the way I want it. So this this notebook works with Python code. And Python allows all these immediate interactions, but you can also go with better languages than Python. But you can also use better Python if you like. For instance, you can also, if you don't like that Python is untyped, you can make the whole thing. You can also add type annotations to that, and you can also run a static type checker that will automatically check whether things are correct. And of course, simply trying out things yourself in here is one thing. Okay. The nice thing here is that your experiments actually are preserved in the document, so the inputs and outputs are actually in there. But you can also just go away and write and put an assertion in here. So what do we have? We want a factorial, a set factorial of 1 is 1, and we also want to make sure that factorial of 3 is 6. And well, what other things do we need in here? I think the factorial of 2 would also be interesting, because that would also be something where people make mistakes, including myself. And now you have these 3 assertions in your document. And the nice thing is that these assertions that you put in there act both as documentation of what your function is doing, number one. But second, they also act as test cases, because whenever I will later on run this, whenever I will run this again and again, any change I make, I can always rerun these assertions, I can rerun these tests and make sure that everything works as expected. Of course, if this all were Java, I would now go and build some whatever big factorial test factory facade, whatever big thingy, unit test runner, something like that. And I would then run the big unit test runner and have a black box whatsoever. This is all nice, but this takes ages to build. See, in here, I just have these 3 assertions and it's all fine. And I can also turn this into formal unit test, but actually having this right in here, having these assertions right within my document actually makes the whole thing far more understandable and far more readable. That's something to think about. Okay, so that was just a very simple example of, this was just a very simple example of a Jupyter Notebook. Now, when we are building code, in academia or generally in science, frequently it looks like this. We are building together huge kludges of systems that eventually produce the one single table or the one single thing that eventually comes out of it, and that we can put into our papers. The papers remain. The code that we built is eventually being thrown away. And this is all pretty much okay if you consider the paper to be the end of all things. But the poor folks who have to rebuild this whole thing, this is just horrible. Just yesterday, I was reviewing a paper where people would be using a big array of double Q neural networks combined with formula learning, combined with program synthesis, one big pipeline after another, in order to improve a single number from 10% to 12%. This is all neat, and we have these huge things, but do we really understand what we're doing here? I frequently have doubts about that. So maybe we should go back to a style where we actually can document not only the final number, but actually all the process that went into it. And for this, tools like Jupyter Notebook are just great. So the thing that I have been thinking about a lot in the last year is not whether such Jupyter notebooks are great for organizing science. They're pretty great at that. But rather also whether such rich documents can actually be a general model for coding. And the idea is as follows. When we are creating code, we're having our implementation. This goes into our .c, .py, .java file, whatsoever. We have an interface, which is, well, a reference document. Then it becomes frequently outdated with respect to the implementation, but the interface can also be in code. Okay, that's slightly better. We have a specification which goes into documentation, and then it definitely will definitely will run the risk of it being out of touch with the implementation. We have rationales that explain why the whole thing is as it is. Well, we should have them. We rarely have them. I yet have to see a documentation in some piece of code that explains all the various ways that the programmer tried in order to achieve things. But what we see is just the final one thing. And we could have many more of such rationals. We have tests. Tests work. Tests can well be automated, but also come in separate files. We have the architecture, the model, which of course goes into an entirely separate document again. And we have tutorials which explain how the whole thing should be used. We have textbooks, how to use things. We have questions and answers for frequently answered questions. We have Stack Overflow where people exchange things all along the way. And the question is, why do these things all have to be in separate places all along the way? What I'm thinking of is ways to keep these things consistent, is ways to actually get all these together in the first place. And the idea here is to have one single way of putting these things together in a single document where we can have everything, the implementation, the test, the architecture, the rational, questions and answers even. And I call this concept illustrated code. See, I'm code-centric here. I'm code-centric here. So it's definitely the code that is illustrated with everything else. But you can also call this illustrated architecture and then say that the code is just some implement. It's just a detail of the overall architecture, if you prefer that. And the idea here being that with everything being in one place, I want this to be in documents that are executable, that are self-updating, and that are self-checking as a neighbor. And indeed, Jupyter notebooks are quite a step towards this way. So let me illustrate this concept using a very, very simple case study. We're having a function middle, which takes 3 integers, x, y, z, and it returns the middle of the 3. What is the middle of 3 integers? You have to define that. It's the one that is neither the maximum nor the minimum of the 3. Okay, so this is, and we want to define tests and specification and interface and tutorials for all of this in one single document. So how do we do this? Let's first start with the interface. We define an interface for middle here. And for this interface, well, we can do a standard way of documenting things. That is, we define an interface. In Python, such an interface simply comes as a function without a function body. This is, well, other languages have better ways of doing that. But this is a standard way of doing things, also in other languages. We also have a comment that explains what the function is doing. That's all neat. But you see, is this enough for telling you how this whole thing works? What is the middle, actually? I told you earlier, but would you be able to infer that from just this comment? Is there a usage example of how you use it? This is the thing that people search for in Stack Overflow over and over. How do I put all these functions together in order to achieve something? And also there's, of course, no implementation yet. We'll take care of this later on. Next thing is the specification. What is it that the code should do? Which means that we're using some more abstract form of explaining what the code should be doing. And we can actually do this also in Python by using a very simple form here. We're just creating a list out of X, Y, and Z, and then we sort the whole list And then we return, well, the second element of that list of 3, which gives us obviously the middle element. And this is actually also an implementation of middle. It's not a very efficient implementation because you need to invoke a sort function every time, convert this into a list. We'll come to this later. But this can serve as a reference. And actually, it's also executable, so we can actually include examples, such as what should the middle spec of 5, 4, and 7 be? Well, this should be 5. And as we've seen earlier, we can also write assertions such that we can use these assertions as tests later on. Our specification document can actually be pretty rich. It can also contain diagrams and more. So as an example, this is just a small diagram, assuming that we do have a server that actually provides a middle service. I always thought this was a ridiculous example until I've learned that there's JavaScript packages which provide comparison functions and other super tiny stuff. Okay, great. So let us build a middle server and let's assume we can send a request to the server and then we can get this back. By the way, I'd like to point out that creating such a diagram in any of the tools that I've ever used before is a total pain. You do this in LaTeX, and then you're using some TIX package for doing so, and it's horrible. You're doing this in Google Slides, and then you have to create drawings, which is even more horrible. You do this with any drawing program, it's also horrible. If you do this in Markdown, there's packages which allow you to actually create sequence diagrams by simply specifying what the sequence diagram should be. And you can write this in 3 lines here. You simply say, I want a sequence diagram, and have a client talking to a server sending this, and have a server sending these things back to a client which returns this number. When I saw this first, I wanted to cry because it reminded me of the countless hours I had prepared of preparing such diagrams and in the past, and now I can do these things. I can do these things so easily. Even better, you can create these text, this Markdown text, from another program, and then you can render it right away. So you can actually go and create these diagrams on the fly. You can use this for debugging, for figuring out what's going on in your program. Ha! Great stuff. Okay, let's use this as a specification means for now. Coming up next is the implementation. Now we don't use the sorted function, but we actually provide an efficient implementation, which comes along with a minimum of comparisons. I don't know what the maximum number of comparisons that you need to do in here is. I think the maximum number is 1, 2, 3. There need not be more than 3 comparisons in order to find out what the middle element actually is. Please check it. It works. How do we know it works? Implementation is still as it was before. Okay. Once you have that, it's executable, and the test and the results. So your own attempts to work with this actually become part of the documentation. And later on, people can not only be, whoever reads your document will not only be able to read the implementation, but will also be able to read the way that you interacted with this. And this is helpful for programmers later on who want to understand how to use your functions. Coming up next is rationals. Why is the code as it is? Well, you can actually also make this part of your document. So we're saying that our middle function, which goes with comparisons, is faster rather than using the sorted way. And we say, so it's faster. Is it actually faster? Well, that's very simple. You can create a benchmark that actually compares the two and measures the time. And you can find out that it is twice as fast. And if you can even document this with an assertion, you can even, and if the Python implementation should ever change such that your rational no longer holds, then the assertion will fail, and then people may actually prefer the shorter middle spec version, which uses sorted instead. You can even come up with more alternatives and evaluate them, and eventually have the document choose the best implementation. And this reproduces all the thoughts and experiments of the original program. Actually, this is what Jupyter Notebooks were built for, in order to reproduce these thoughts and experiments. If you're doing data science or any kind of experimental science, you can document your stuff, but this actually also holds for regular programming. Okay, And yep, you can do, and you can check, you can have the document check automatically whether the rationale holds. And this actually also makes sure that the text that you're writing, when you're writing, it is about twice as fast, okay? If you do this in a regular document outside of your implementation, the risk is always there that this becomes outdated. But if you do have an assertion that actually checks whether the statements you made in the text actually still hold, okay, then you can ensure consistency between the text and the code, because all the factual statement that you put into your text would automatically be evaluated by such assertions. At this point, I always think it's absolutely time to get rid of LaTeX and all the other stuff that we use for producing our scientific papers, and actually produce papers that contain such assertions, such that our statements such that our statements can actually be formalized, and that we can actually check these automatically. Also, should the data or should the language or whatever ever change. Coming up next is tests. We already have seen tests. You use assertions. You can use assertions for that. And these tests actually act as additional examples. Examples act as tests. Tests act as examples. And if anything ever fails, the assertions are going to catch it. These days, I get plenty of assertions that fail simply because somebody out there in the world updates his Python code such that it becomes slightly incompatible. Nice thing is, my assertions eventually catch that. And of course, you can also come up with richer tests. You can come up with tests, for instance, that compute something like test performance, that compute coverage and like things, because you can very easily program these things. Here, for instance, I programmed a small function that computes code with coverage, and it automatically produces a listing of the code, and every line that is executed automatically is starred in here. You can also compute the coverage as a number and make sure that this coverage actually has a specific, and then you have a specific minimum coverage in here. And if through whatever means your coverage should now be less than 100%, well, then these assumptions can also become, can be put right into your document, okay? So typically, all these things, again, come in separate documents. So you have your tests, and then you have something to run your tests, and then you look at the number that this tool produces, and then you, as a human, have to check whether things are still right. Here we have everything in one place, including all the assumptions you make about tests and test quality. And of course, you can also make much richer tests, because you can also come up and create thousands and thousands of random values, and make sure that your middle implementation actually is the same as your original specification. All this is possible right away. It takes about a second or so to execute. A second would be slow. Oh, we can measure that. We can measure how much time it took. And if you are a true believer of full symbolic verification, you can also run this right within your document. This is an example using the Z3 solver. So you can create a solver, you can create 3 symbolic variables, and then you can encode your individual, then you can go and encode your individual assumptions, the individual constraints, as you can extract them from your program. And then you can find out whether there is any way that the number you're getting out of your program should not be the middle, and actually prove correctness of your program also right away in your document. As much as these tools go, of course, but yes, everything becomes one document. That's the fun part here. Okay, how is the code organized? We already saw this originally in the specification, but we can also extract such diagrams from the code, keeping it up to date. So I'm building a little server class here, which has a state and which offers 3 services: middle, min, and max. And I can now go and create and write a function that produces a class diagram. Here we have a class diagram, max, middle, mint, blah. This is just whatever UML style. And these can also be dynamic, as we've seen before. This is a simple class. I think it's the 12 lines of code, which actually takes an execution and automatically traces all the functions that are being invoked in here, also traces the return values. And this is the diagram that the whole thing produces. So again, I write sequence diagram tracer, and out pops the diagram that actually was run in the actual execution. This is so great for debugging, because then you can immediately see, get the diagram out, and you can immediately see what was going on. And again, this all becomes part of one document. And you could even go and compare this document that you get out of your trace against the original spec, and then find mismatches. Is there anything in the interaction that does not fit the original spec? This is very simple because, well, you just have to compare the abstract markdown code here. This is a pleasure, I tell you. Okay, you can have tutorials on how to use or extend this. To use middle, you use Python, whatever. You need to install things first. These actually work for the fun of it, so you can actually run these. You can actually run these very commands in here. So you import appropriate functions, and then you can invoke it. This is something that you can also make part of your document right away, so people can find everything in it. You can find the specification, you can find the code, you can find the tutorial, you can find the tests all in one place. And if these do not work, if these instructions do not work, you would also immediately find them, because when you're running your entire document, you would also run the tutorial. You would run the tutorial and find out whether things do not work. In my tutorials, I even have screenshots in there. So I'm running a browser remotely controlled by Selenium, and I'm taking screenshots of that browser. The screenshots become part of the tutorial. And lo and behold, if anything in there does not work, say because somebody has moved a button or because somebody has rearranged the screen or anything, I immediately get this because there's a failing test, and I can update the tutorial right away. No chance ever of these things getting inconsistent with each other. And the question and answers. This is an idea which came from Greg Wilson. You could also add question and answers to the whole thing. So you could also say, okay, you can have questions from individual users, and these answers would also become part of the document. This, of course, raises questions of who's allowed to change the document, or who's allowed to change which parts of the document, and who's allowed to provide answers. How can we do that? But you can easily figure out that all of this, that the questions about things and the answers about things also become part of this entire document, because then you can rerun them at any time and again check whether the answers that other people have provided before actually are valid. Not like in Stack Overflow where, oh, I am searching a particular Python function, how I'm trying to figure out how to achieve things, and I need to wade through dozens and dozens of answers which are outdated, which don't work anymore, and I have to figure out which of these things work at all. It's a pain. Well, at least there is somebody. And if we have things right in here, we can also execute them right away and always keep track of whether the answers still hold. Okay. Let me get back to my vision here. Everything in one place. Tests, specification, interface, architecture, tutorials, rationals, implementation, of course, question and answer, which are computable, which are checkable, which are rich, which is absolutely fun to read, or at least much more fun to read than regular program code, which is also much more fun, which is also interactive. So you can try out things yourself, which also adds to the fun of reading things. It's also more fun to write, because you see, you're having your thoughts. You're having your thoughts of how to do this. You can jot your thoughts right away into the document. This helps you when developing. This helps you during debugging. It's not like you first implement something and then later on you're forced to write some documentation for it. This is horrible. No, you have everything in one place and you develop things. You're experimenting with things as you develop them. Things are always up to date, and there's plenty of ways to export synergies in here. So I'll very, very briefly tell you that this is actually not something that I have invented, or that I just postulate would be possible. But actually, all these things are right here in my Jupyter notebook. I implemented all of this, and you can find out that this is actually all very quick and all very executable. So let me see whether I can run things here. So here again is my factorial function, and here comes the middle function specification. Here is a rational with a property experiment. What happened to middle? I didn't implement middle. Oh, so sorry. I have to cheat here. Okay, let's go into the actual document. Here we go. Always good to have a backup in here. So I can execute this whole thing, and in this whole thing, you will find that I have a middle benchmark. I can actually also compute the time it takes to run appropriate tests with various implementations. I have all these assertions that actually check whether my documentation is actually in line with the facts from my experiments. I have regular tests. I can compute coverage in here. I can check against the specification, and I can even run a symbolic verifier, which just seconds ago has told me that the whole thing is that here there is no way that middle would not return a middle. And since you like this so much, here are class diagrams which I can automatically execute. Undefined. Okay, good. I still have to update this. Okay, I'm so sorry about that. I wanted to show you how neatly this works with the. That's it. I executed this the last time about 6 months ago. Now something doesn't work anymore. So I know that this is something that is not going to work. I definitely have to update this. There's a tutorial which does all that. And here again, we have the Q&A, what's wrong with middle. Everything is in here. And there's even a bit of more drawing of UML, which also you can also create state diagrams and whatnot. And in the end, I have a couple of resources. I will share this entire document with you in a way that you can actually go and execute it yourself right within the browser. There's alternatives to what we're seeing here. There's literal programming, which gives you rich documentation with tech, with web structure. That's nice. But this does not include any examples, no outputs, no tests. It's not interactive at all. It was absolutely visionary at the time when it was first designed. But life has progressed quite a lot in the last 37 years. You can also use rich comments, of course, and this is great if you prefer to work in a text editor. It's all text. You have to write your examples from hand. You have to write your output from hand. It's not interactive. There's no tutorial in here. So that's also not a perfect alternative in here. There are libraries for Python projects to use Jupyter notebooks, which already get close to the vision that I presented. But this works only in Python, and there's also no specific writing philosophy that comes with it. And my agenda for this is something for us as a community in software engineering to explore, because notebooks are great, but notebooks also suck in terms of features from software engineering. So as an IDE, as a development environment, they're not very adequate. There's plenty of things that are missing. You would want some automatic refactoring, for instance, and other stuff. This is not there. Search and replace now works, finally, sort of. Code completion somewhat works, but it's nowhere near what you have in an integrated development environment. Also, in terms of, you see, this document simply is linear from beginning to end, but you would like to have individual sections. You can have sections, but you want to have the whole thing a bit more structured from the very beginning. You want to make sure this is where I have my tests, maybe this is where I have a bit more of a tutorial and like things. Like now, this simply is linear. There is no modular. There's no concept of modularization, both from the concept of organizing your code. Well, a notebook simply is a module, there you go, and then you have to live with that. But it's also from a programming language, there simply is no way to simply have a block in there in which you can execute something without affecting the global state. There is one big global state with plenty of global variables too. Well, there is one global state per notebook, okay, so far so good, but from a programming perspective, this is suboptimal. And we already mentioned that there is little modularity, little reuse across notebooks. By default, it's not even possible to import one notebook into another notebook. You have to write your own code that does that. Well, you can always do that, in particular in Python. But yep, this is where we are. And as everybody knows here too, if you want to program in the very large, the default language of Jupyter Notebooks as we have it right now, which is Python, is not at all perfect. If you want to produce really big, really reliable software, then Python, you're going to hit the wall at some point. Okay. On the other hand, development environments as we have them are not the answers either. We are still super type-write centric because when we invented interactive computers in the 1960s, all we had was teletype systems, so everything is still a teletype at its very foundation, and everything is still typewriter, which is which is something we don't see anymore on the web, but we still use we still typewriting all along in our code. This is something that needs to go. We want rich documentation, we want things that are interactive, examples, tutorials, everything in one place, such that we can catch consistency also between documentation and code. And this means several things here too. We want IDEs to come up with better and richer documentation. We want to have notebooks that have the powers of IDEs. We want to have notebooks that support C, C++, Java, Rust, better languages, still in an interactive style without me having to invoke the compiler for every single function that I'm executing. Notebooks should be first-class citizens in programming. We want them to be collaborative, as in Stack Overflow, such that people can ask questions and answers. And tutorials, illustrations, and examples should actually be a part of standard coding. If I see a piece of code that does not come with a tutorial, that does not come with illustrations, that does not come with examples of how to use it, we should consider this inadequate. And we need to do more research on research software. We need to do more research on what makes notebooks special, successful, and how we can use such specific features to create better software. With that, I'd like to close. We've seen how current knowledge about code is distributed in lots of individual documents, which can very quickly become out of date. Standard problem in software engineering, standard problem in any kind of software. The idea is to put things together in one place where we can ensure consistency at all times by executing things with rich documents that provide a large variety of outputs and output formats. And yes, there is quite a thing to do and